All right, welcome everyone. Let's go ahead and get started. My name is David Hazar, and I'm going to be taking you through a preview of some of the content for SEC 549, which is one of the courses that I co-author and teach for SANS. I have been doing IT and security work for over 20 years, closer to 25 now. For a variety of different companies. I went and worked for Deloitte for 3 years as a consultant. Did a lot of work there in the application security, which bled into the cloud security space back when it was becoming more and more popular. And then for the last, eight or 9 years, I've been an independent consultant and been doing training for SANS in addition to work for other clients. I'm also an IANS faculty member. I co-author and teach this course and Leadership 516, which is building and leading vulnerability management programs. And I've also taught for around 6 years SEC 540, which is the Cloud Security and DevSecOps Automation course. Today, we're going to be focused on the content from 549, which is our Cloud Security Architecture course. Now, another exciting event is that we have our certification that just came out. We've been teaching the class for a while now, but we didn't have a GIAC certification. Those usually come out after the course has been around for a while. That is available for pre-sale. And so January 25th is when it'll actually open up and you can take the exam if you're a previous student. But if you're looking to take the course, you can add that on and we'll be able to take that and get certified. Also, we have another webcast coming up January 23rd with Brandon Evans, who authors and teaches 510, which is our one of our other cloud security courses, the Cloud Security Controls and Mitigations course. He's going to be talking about ransomware and how the cloud can help if you take the time to build and secure it the right way. All right, let's get on to today's content. Today, we're going to be going through just a brief preview of each of the different days of the course for 549. In 549, we start off talking about identity and access management. We spend pretty much the first 2 days on identity and access management. Why? Because that is the foundation for security in the cloud. Since everything, at least via the APIs for configuring our resources, is now public facing, we've got to make sure that we invest time and effort in making sure that we have our organizations set up correctly, maybe consolidating some of our identity via federation or something like that, and then putting in place the proper access controls based on principles like least privilege and things like that. And so the first day we talk more about that from a workforce and cloud user perspective. And then on day 2, we look at it more from an application and workload perspective and get into some of the cross-cloud authentication. On day 3 of the course, we look at how we can simplify our networking in the cloud. And when we go through it, right, obviously in smaller organizations that just have a few VPCs, this is going to be, we're going to look a lot more complex. But what it allows us to do as we centralize our networking and centralize our control in the cloud is it allows us to drop additional workloads into the cloud very easily and have some basic controls already in place, already standardized, and get visibility and control over those new segments right away without having to kind of redo a lot of our routing and security group rules and all of that stuff. It simplifies things by kind of centralizing all of that, all of those capabilities. And then on day 4, we talk about data security. And so we're going to look at some of the different storage service security options that are available in the cloud and what we should be looking at there. And then on day 5, we look at logging and incident response. And what we're going to be covering today is our break glass accounts and how we deal with break glass in the cloud when we need to give our incident response team additional privileges or permission to do things as they respond to incidents. How do we do that safely? And one thing that I'm going to kind of touch on that it hasn't quite made it into the course yet, we do discuss it a little bit, is how do you deal with break glass accounts now that the cloud providers are requiring MFA, right, for all accounts? Because a lot of the time, even one of our recommendations was have an account that doesn't have MFA. That way, if the MFA service or the MFA capability is down, you can still get in and respond to events. And so I'll give you some different options that may help you still provide some of those capabilities and get around some of those MFA controls. Not that we're trying to get around them. Obviously, they're there for a reason. But we'll talk about some of the ways. And then anytime those accounts are used, obviously, that do not have the MFA enabled, we should be aware of that and have alerting so that we can respond immediately if it's not one of our incident response team members. So let's first take a look at some of the differences in the IAM architecture for the different cloud vendors. In Azure, our identities are contained within an Entra ID tenant, and that tenant can be attached to one or more subscriptions. And so that's kind of the basis of our identity inside of Azure. I'm just going to pull up the question and answer so I can see it here. We do have a couple questions in here already. I don't know the answer to the first one, Michael. Maybe Hayes can get an answer to that one. And then the work study, you can apply for work study for those that aren't aware of the work study program. It is available and out there. I think all courses are available. It's just depending on registration, whether or not they need somebody to help with the course. And so you just sign up and, based on the number of people that are registered and the help that they need, they may accept that application. So usually when you apply, or at least when I've applied in the past, you pick like your top 3 choices for courses that you'd like to take, and you might not get your first choice for the work study program. All right, so back to Azure. Entra ID, you have your tenants. Now, you can have more than one tenant. For those of you that have classified networks or that are working in GovCloud, you most likely have multiple tenants, one for your commercial stuff or one for your less classified networks, and another maybe over in GovCloud for your more classified stuff. Or maybe it's all in GovCloud and you still might have separate tenants there. There is a way to grant access cross-tenant, but it's a conscious choice. If I want to give somebody outside of my tenant, even if that other tenant is part of my organization, if I want to give them access to my primary tenant, then I need to make them a guest of my tenant. Now, if the tenants are both owned by my organization, I can use cross-tenant synchronization through Microsoft's external ID service to make that easier to basically bring some of those users over into my other tenant so that they can have access without having to have them maintain multiple accounts. If it's a third party or somebody else, then I've got to go and invite them and have them join. And as long as their tenant settings allow them to be guests of other tenants, then I will be able to invite them over. There's some other caveats in there, like commercial and GovCloud, they're different things. They're different cloud environments. And so you can't make a commercial user from a commercial tenant a guest of your GovCloud tenant. And so if you need it to have a partner access your GovCloud, they would have to have a GovCloud tenant as well. And then you could invite their guest to come over. You can invite their user from their GovCloud tenant over into your tenant. And so there's lots of this that we need to understand so that we can put in place the proper controls and the proper design and architecture within our organization. And then we've got to decide, do we want to simplify and not, do we really need the additional security that comes with having multiple tenants? Because that's a huge isolation boundary, right? Where we are now consciously inviting users from one tenant over into another. For some organization, the complexity of having to manage multiple tenants doesn't provide the benefit to justify the added work and the added complexity. But for other organizations that have either more sensitive business units or are really wanting to isolate certain workloads and certain information, it may be worth it, right? If they want to have less impact, if some of their general services are compromised, and keep things more separate. In terms of the life cycle of guest users, again, that's going to be highly dependent on your organization and the needs. I would say that it's probably something where it would be worthwhile to set up a workflow where that guest access is requested and approvals are granted, and maybe it's harder to get approval if that guest access is permanent or more long-term, where if they're asking for access for a week or something like that, then you can streamline that approval process as long as it's not like broad access, it's granular access as well. And then have a notification that goes out to remind administrators, or have automation in place would be even better to remove those guest users when that expires. But that's something to just think through for your organization. If it's another tenant in your organization, like let's say you acquire another company, they have a separate tenant, then that might be one of those cross-tenant synchronization type setups where it is more long-term, and that might be more of a one-time approval process for all of the users versus each individual user. But for your partners, you probably want to have a workflow for that. So the other question was for guest access process for users who affiliate. Yeah, I mean, definitely you can try and keep those separate and have different workflows for more partners that are going to be potentially having access to more things or longer term access versus the guests that are more clients or prospects where they may need access for a trial or a demo, and then that access goes away. And that goes back to the workflow. If you can build that out and build in some automation to manage those users, that would be very, very helpful in not accidentally leaving that guest access beyond its useful life. Now, within Azure, the way that we get access for applications, for virtual machines, and things like that is via service principals. And in Azure, those are stored also within your Entra ID tenant. Now, there is for managed identities a separate Azure Cloud blade for managed identities where you can manage those, but they are also stored in Entra ID as service principals under the enterprise applications section of the menu there. Let's see, let me address this question real quick. From 2024, if you probably could use the same books because it hasn't changed drastically. But I don't know, they may offer you the ability to get the new books for a small fee, and there are going to be some small changes in the last year, but I don't know if it would be significant enough. The one way you could figure that out is with the practice tests. If you're noticing there's a lot of new stuff in the practice tests that you don't have in your current books, then you could see if you could request some new books, and I think there's a fee for that, but I'm not clued into all those details. All right, so service principals are how we grant the yeah, this will be recorded and you'll have access to it. Sorry. Let me maybe let me just what I'll do is I'll go ahead and go through this so that we can get through the content, and then we'll have a longer Q&A at the end. I'm happy to answer questions. I just want to make sure we get through all of the slides, and then I'll come back to the Q&A. These are great questions. Make sure you're writing them down so that we can cover them at the end, but I do want to make sure that we get through the content. Now, the way permissions are assigned in Azure, because we're going to see some differences in AWS, is through role assignments. And those are bound to a resource. Now, a resource could be a resource group if we want to provide access to everything under that resource group, or it could be an individual cloud resource like a virtual machine. And there's a bunch of built-in roles that contain API permissions that we can grant to our users and our groups. Groups are useful because now we can ensure that there's always at least 2 people that have those permissions, right? And that's just a general good design principle, is to use groups rather than individual users to assign your permissions. And that works well in Azure. It gets a little bit different in AWS when we talk about that, and we'll talk about some of the differences there. In Google Cloud, one of the biggest differences that we have in Google Cloud is that you do have your Google workspaces or Google Cloud identity directories where you see your users. But it's a little different than Azure. In Azure, that tenant separation is, they're separate things. In Google Cloud, those Google Workspaces and Google Cloud Identity directories, even though they only show your users, when you're using those to assign permissions, it's when you're going in to do role bindings, to bind roles to resources similar to our role assignments in Azure, you actually have access to all Google accounts, unless you've done something to restrict that through organizational policies. And so if I go into my Google Cloud environment, even though that's tied to my Google Workspaces or Google Cloud Identity directory, when I go search for users to add, I can actually go look up my personal Gmail address and give my personal Gmail address permissions to resources within my cloud environment. Now, that might not be what you want, and there are org policies that you can use to address that and to pick the domains that you want to allow to be given permissions inside of your cloud environment. And that can differ based on where you attach that policy in your organizational hierarchy. And so it's any Google account. Service accounts are the corollary to service principals. That's how you give access to applications. That's what's used a lot for our federated access or cross-cloud access. We'll impersonate a service account to get access into the cloud environment. And then we have the role bindings, which are similar to the role assignments that I already mentioned. And this is similar to Azure, other than Azure is really the only one that has that resource group bucket. In Google Cloud, you have projects, which are, I guess, more like subscriptions or accounts on the AWS side. And you can bind permissions to those projects just like you can subscriptions. There's just not something below that, like a resource group, to separate out your resources. So below project, you're going to the individual resources that you're creating in the cloud to bind those roles. And there are built-in roles. You can also create custom roles, and that's the same as Azure. I'd say Azure and Google Cloud, in terms of assigning permissions, are the most similar because they both call their sets of permissions roles. Roles is a completely different meaning in AWS, and they're bound to resources, where AWS has a split design between identity-based policies and their resource-based policies. All right, now for AWS, which is the most unique. identity is siloed in each AWS account by default. That means if you're not using AWS IAM Identity Center, all of your users are spread across all of your different accounts. If people need access to more than one account without AWS IAM Identity Center, and technically with it as well, but it just manages it for you, they either need to have users in each of the accounts, or they need to have a user in one of the accounts that has access to assume roles in the other accounts. And doing that manually is a little bit more cumbersome. And so when they came out with AWS organizations, they also implemented AWS single sign-on shortly after, which then became IAM Identity Center, for you to create a central directory of users inside of the management account, or it can be delegated for administration over to another account. And that's where you can manage those users, and you can assign what are called permission sets, which are policies that contain specific permissions, and then basically bind those to groups and users for different accounts. And that will automatically create a role over in that other account that user or that group can assume in order to get that access in that account. And if we have some time at the end, I can maybe show you around our live lab environment, where as a student, you'd have read-only access to go in and look at some of these different settings and kind of explore some of the things that we've talked about. It doesn't have everything that we cover in the course, but I'd say 70 to 80% of the things that we cover are in our lab environment. Now, roles are not the same thing in AWS as in Azure and GCP. Roles are not collections of permissions. These are like service principals or service accounts. They're the things that we assign to EC2 instances or Lambda functions to give those identities. It's what we use for the cross-account access and federation and things like that. Now, your permissions, your list of permissions, are defined in policies, and those policies are attached to identities, or they are attached to resources. And the way I like to think about that is my identity-based policies that are attached to my user or attached to a group that I'm a member of, those are my outbound permissions. And within the same account, they're the only permissions that I really need to get access to things. There's some small exceptions to that, but those are the things that I can do. If you're looking at cross-account, which a lot of the times we are these days with our AWS organizations where we've segmented things more into different accounts, a lot of our access is cross-account. If it's cross-account, we also need the matching or corresponding inbound permissions in order to access the resource. That's our resource-based policies. So for instance, if I have a policy assigned to my user or a group that I'm a member of that allows me to do an S3 get object on a bucket that's in another account from where my user is stored, then just because I have it attached to my user doesn't mean I get access. There has to be something on the bucket policy, in the bucket policy, which is the resource-based policy, that also allows my user or my account to access the get object API for that bucket. So I need the outbound permission, and I also need the inbound permission when it's cross-account. If it's same account, then I only need the identity-based permissions. The exception to that would be key policy. If you remove the default key policy, then that's a minor exception to that. And just to highlight this, DynamoDB only recently got resource-based policies. So before you had DynamoDB, without the resource based policies, in order to get access to DynamoDB from another account, I was required to assume a role in the account where DynamoDB existed, because there was no resource-based policy to have both the outbound permissions in the account where my user is and the inbound permissions to validate that. And so it wasn't safe, which means the only way for me to get access to that with their design was to assume a role in that other account that had the permissions, the identity-based permissions, to get access to that DynamoDB. Because it's the same account, that's allowed. Resource-based policies came out after identity-based, and this goes back to those architecture design decisions. When AWS first came out, it was like, oh, everybody's just going to have one account. It'll be fine. They'll just separate things out. Eventually, they had VPCs to provide that isolation at the network layer. And then they realized, oh, wait, no, people are going to want to have multiple accounts. We've got lots of customers that want multiple accounts. How do we do that safely? Right, we've been doing these identity-based policies, granting permissions directly to users and groups, but we need some way to secure the other side, and that's where resource-based policies came into play. I mean, bucket policy kind of existed before that transition, but it was really based on, like, you couldn't get very granular. It was more like looking at the user agent or the IP addresses and things like that. That's what bucket policy was when it first came out. Now it's turned into something that's very similar to our identity-based policies. It's just the inbound permissions versus the outbound permissions. Now, groups are useful in AWS, and you can use them to apply the same identity-based policy to multiple users. The problem is with groups is on the other side, in the resource-based policy, I can't reference a group as a principal in my resource-based policy. I can reference a role, I can reference a user, I can reference different things, an account, but I can't reference a group. The way that you can still use groups, as long as you own both of the accounts, because you don't want to do this for accounts that you don't have control over, is you can, in the resource-based policy, give the account permissions. And then in the identity-based policies, that's basically when you give the account access, the account doesn't have access. Nobody in that account gets access implicitly, except for maybe the root user, but those are hopefully going away with the root account management. But the users in the other account that you're trusting in that resource-based policy now have to have the identity-based policy that gives them the outbound permissions. Since the entire account's trusted for certain API calls, if we grant those same API calls in the outbound permissions or identity-based policy, they'll be able to access those resources because it'll match based on that account ID. That's how we can still use groups, even though they can't be referenced as principals in your policy, is by trusting the account. But when we trust an account, we've got to trust the IAM administrators of the other account that we're trusting to apply the appropriate fine-grained access controls. And if we can't audit that, if we have no visibility into it, if it's an external party, then we want to use users or roles and have those as what is used so that we can put those principles in the policy. And so just quickly to wrap that up, identity-based policy, you have your actions. Those are the APIs that they can access for the different services. You have either an allow or deny. And then you have the resource. And you can sometimes get more granular and go down to like certain prefixes or paths on that resource. But that's your identity-based policy. The main difference with a resource-based policy, which is bucket policy, key policy, things like that. You know, there's secrets manager has resource-based policy as well. On that side, right, you would have an additional principal attribute in your JSON policy document. And that's because that's the inbound permissions. We're giving certain API call access to certain principals, typically in other accounts, through our resource-based policies. All right, if you have any questions there, we will cover them at the end, so keep track of those. Now let's talk about cross-cloud authentication. For our cross-cloud authentication, we have a couple different options. The most basic and the one that a lot of people are using today is for AWS, an access key and a secret that's tied to a user account somewhere in our AWS environment. In Azure, a service principal with a secret. In Google Cloud, a service account with a service account key. Those are all long-lived credentials that we have to manage. We maybe have to rotate them and update and give those other applications the new key just as part of our compliance standards and things like that. We may have that rotation scheduled, and that can be difficult to manage. And so another option that we have that we could use is setting up federation that allows us to have temporary keys that are used and validated to access those cross-cloud resources. And so let's look at some different examples using those two methods. If we have a pipeline hosted in GitHub, a GitHub action, we can put, let's just use Azure here because that's what we're using in this diagram. We can put a service principal, client ID, and client secret inside of the secrets management capability in GitHub. And our pipeline can use that to log in as that service principal and deploy an application on top of a virtual machine. Now, as part of that deployment, maybe it also sends to the application some access keys for a user in AWS and a service account private key for Google, along with the details on the service account that's associated with that key, and then also the key ID portion of these access keys. And then this application can use those to retrieve or store data in the different cloud storage services for these different cloud vendors. And that works, but if that machine, that virtual machine gets compromised, or if our pipeline technology gets compromised, the attackers have access to a key that lives until we rotate it, until we notice something is wrong and we rotate it. Much longer lived than what we'll see in the OpenID Connect example. So the way this changes is GitHub, GitLab, and a lot of other providers have an OIDC issuer where it can issue OpenID Connect tokens. We'll talk about what those are in a second. They're JSON web tokens. They're a specific type, a specific format of JSON web token. And in my pipeline, I can request a JSON web token or OpenID Connect token that has an audience of Azure, right? And that's not really what it's called, but like I can set up the trust relationship on the other side to trust a specific audience. And I can request tokens from the GitHub issuer that have that audience, and then also have a subject that's related to my GitHub repo. And then on my service principal, instead of setting up a client secret, I can click on the Federated Credentials tab, and I can set up a trust relationship to trust tokens with a specific audience and with a specific subject from a specific issuer. And that allows GitHub to log in as this service principal, and it still has tokens that can be stolen if somebody gets access to my pipeline, but those tokens only live for a period of time. And depending on cloud provider, it could be an hour, it could be a day. There's different expirations for those different issuers. So we can use that to log in as the service principal, deploy our application on top of our virtual machine. Well, this virtual machine, because it's Azure, already has an OpenID Connect token. If we've assigned a managed identity to it, it already has an OpenID Connect token. We don't have to do anything to create that or generate that. There's something that's built in to our managed identities that provides those tokens. Well, we can take that token and we can exchange it with some additional configuration in AWS or Google Cloud for a role credential or a service account credential. We can use that token to log into AWS and Google Cloud. And again, if somebody compromises this virtual machine, yes, they can steal the managed identities token, but they can only use that for a period of time. OpenID Connect is an extension of OAuth. It was built on top of the OAuth standard because OAuth 2 and even the first version of OAuth, maybe even more so the first version, were intended for authorization, not for authentication. Lots of people were trying to make it work for authentication as well. And that led to some insecurities. And so they decided to come out with a standard like this. If you're going to use this for authentication, this is how you should do it. And that led to this OpenID Connect extension that allows us to do authentication in addition to authorization using the OpenID Connect standard layered on top of the OAuth 2 standard. Within OpenID Connect, we have identity tokens. Technically, there's access tokens and refresh tokens as well, but these are used to authenticate us to different services, and Google and Azure use these for all of their access in the cloud. Like when we log into Azure and when we log into Google Cloud, we get OpenID Connect tokens that allow us to access those cloud providers. In AWS, they still use IAM credentials, which are the access key and the secret that are used to sign and put inside of the authorization header a signed payload that authenticates us to the APIs. And so it's kind of different. When we talk about using OpenID Connect for cross-cloud authentication, it's a lot easier to do it from Azure and Google to other cloud providers than it is from AWS to other cloud providers. Because in AWS, we don't natively have an OpenID Connect token to use for that cross-cloud authentication. But you could still do it potentially with Cognito. There's another service where you could potentially get a token. Lots of my clients will use the certificate-based authentication. That's another more secure option than our secrets and our service account keys, is to use certificate-based authentication. Still maybe not as good as OpenID Connect, because if somebody gets that certificate, they have longer lived access, but the certificates are a little bit more protected than those secrets are. All right, how are these tokens validated? That's what I want to kind of go through. We have within our JSON web tokens or JOTs a header, a payload, and a signature. Now the header and the payload, these are just base64 URL encoded, so we can decode those. And this is what that looks like. Technically, you can do the same thing with the signature, but because it's just a signature, it's going to look like encrypted data. Here we have the decoded header and the decoded payload. Inside of the decoded header for a OpenID Connect token, you're going to have a key ID. Because we're using RS-256, that's a public-private JSON web token. It's signed with a private key and validated with a public key. In the payload portion, we have an issuer. And that issuer is going to be important because it's used by the other side to validate the tokens. In order to validate a token, and we don't have to do this, there's libraries that do this, but I just want you to understand how this happens. In order to validate a token, what the library you use for that validation is going to do is it's going to take the issuer out of the payload, and it's going to go to that issuer URL .wellknown / openid - configuration. And inside of the payload that's returned from that endpoint, there's going to be this JSON web keyset URI, which is a reference to another storage location. In this case, the same issuer URL .wellknown jwks.json. That's our JSON web keyset file. Inside of there, we have that key ID. This is an array of keys, so we're going to have to find our key ID. And then we can use this exponent or modulus values to reconstruct our public key, or there's usually, it's optional, but there's usually an X5C, which is your full certificate chain that you can use, or that your libraries will use to validate the signature on the token. Because we're using that asymmetric cryptography for the signing, to validate the signatures, all it needs is the public key. Public keys are public. And we have this well-known or standard way of getting access to the public key to do the validation. If you receive an OpenID Connect token from anyone, you should be able to validate it. And then once you've validated it, you can look at the issuer, the audience, and the subject and other claims to see if that token was meant for you and to maybe see what access that token should have to your environment. And this can all be configured inside of our cloud environments with some additional trust configuration that we talk a little bit more about in the class. In the different providers, we can set up that trust to say, hey, this token can assume these rules or impersonate these service accounts or log in as these service principals. So now let's switch gears and look at centralized inspection. So the advantage of centralized inspection is now we have one place to control our traffic going from each of our VPCs or virtual networks to other VPCs or virtual networks. We have one place to do some centralized logging. We could still do logging other places, but now we have a centralized place to do that. And we get more control. It also simplifies some of our security groups and network access control lists if we're in AWS. Because if you don't have this centralized inspection, you're having to do all of the control within those security groups, and that can lead to very long lists of rules that, if you're trying to be granular, that are harder to manage, and they're spread out, and so we've got to keep track of those. This is what a centralized hub and spoke design looks like in AWS. And in our live lab environment, we actually have this set up with Palo Alto firewalls set up in an active configuration here inside of our inspection VPC. We have our egress VPC, that's for all outbound traffic. We have our ingress VPC over here, that's for all inbound traffic. And then the nice thing about this is once you get those three spokes set up and configured for all of your workloads, if I need a, let's see, a web server and then an API tier here, and maybe some shared services, notice the routing configuration on this. It's all identical. Every spoke we add now after this, we just drop in the same VPC configuration. You have your locally connected traffic, and then everything else here goes to the transit gateway, which is the service within AWS that allows you to do this hub and spoke networking. Now, the way that you force everything to go through through inspection is with the route tables inside the transit gateway. Because here, everything that's not destined locally for this VPC, and we've micro-segmented, so unless one of my web servers is talking to another web server in the cluster, it's going to be leaving that VPC, and it has to go through the transit gateway. All of these spokes are attached to the pre-inspection route table, except for our inspection spoke. That means that the only place that they have to go is through our firewalls. It goes through our firewalls, and then once it leaves the firewalls, after we've implemented our firewall policy, if it matches, if it's allowed, then it goes to post-inspection, which is the route table that this VPC is associated with. And then it determines, which spoke, or, whether it's outbound traffic or inbound traffic, where it goes next, based on that post-inspection route table. And now we have full visibility and control over that traffic inside of our firewalls, inside of this inspection VPC. And anytime we add a new spoke, we're just dropping that in, adding a couple of firewall policies based on what needs to access those resources over here in our firewalls, and we're done. On the Azure side, we actually set this up using Microsoft's virtual WAN service. And virtual WAN, with virtual WAN, and because our Azure environment's not quite as large, we decided to do an active passive configuration, which really just eliminates one of the load balancers that we need on the internal side. There's some additional configuration. This is all outlined in Palo Alto's documentation on how to set this up. But there's a configuration where if the primary virtual machine that's running your firewall goes down, the secondary virtual machine will notice that and use a service principal to actually move the IPs from the primary over to the secondary. And that's how the active passive works. But this is exactly the same as what we were seeing over on the AWS side, where we have a pre-inspection route table that all of the spokes are connected to except for our inspection virtual network. And then that's associated with post-inspection that has all of the routes back to our other spokes. And so everything goes through the firewalls and then out to the different spokes in our network. It looked like we had somebody raise their hand. Well, if you want to drop something in the Q&A, because I don't think we have a voice channel, then I can address that here as we get towards the end, but I need to speed up so that we have some time here. Now, for storage service security, there's lots of things that we could talk about. I want to talk about a few of these. We care about logging, we care about data retention, replication, encryption policies, and then there's the access control piece that we need to understand. In AWS, we have identity-based policy. Nowhere else do we have that. Everywhere else and in AWS, we have resource-based policy. We need to understand how those work and how we configure those to do fine-grained access control. We might have a third option with our storage services, which are access control lists. Some of the cloud providers are moving away from these. They were there at the beginning because we were used to file and folder permissions on our file systems, and they wanted to provide something similar in the cloud. But the general recommendation, move away from ACLs and go to the resource-based policies, the role bindings, role assignments, or bucket policy. Signed URLs is if we don't want to give somebody long-term access to something, we can create a signed URL, which is called a shared access signature in Azure, signed URLs in AWS and Google Cloud. And that can grant a user without an identity inside of our cloud environment access to storage. If we don't want to make somebody a guest of our tenant, if we have restrictions in Google Cloud around which domains we can give permissions to inside of our cloud environment, then we can use signed URLs as an alternative. Shared access keys are a function of Azure. There are some keys that allow us to Well, one of the things that they allow you to do is create shared access signatures, but also can give you access to storage at a pretty detailed level. And there's a Azure policy that you can implement to disable these. Now, since they are used for creating shared access signatures, you need to make sure that people know how to generate shared access signatures the other way before you disable these. But once you get rid of that, it's recommended to disable these just because they are broad access to storage that's not tied to an individual user. And so if people get access to these, it's harder to audit who's accessing your storage. Now, another important piece of our storage, not only from a security perspective, but also from a cost perspective, which we do care about, is data retention and lifecycle. And if we want to focus, let's just focus on logging here. We might need our logs online for 30 or 90 days. That's when they're most useful. That's when they're more likely to be used by our investigations teams. And so we might, for 60 to 90 days, have those in the highest tier of storage that provides quick access. And then we can tier that. We can move them to slower or cold storage over time and eventually age that out, right? If our log retention is a year or 2 years, whatever that is, we can set up that policy so that we're not continuing to pay for these logs past their useful life. We don't need to keep them forever. Now, there are some things that we do need to keep forever. And that's where we can set up, legal holds or object lock or things like that to prevent people from accidentally deleting those. Versioning is something else to pay attention to in your storage to make sure that's enabled. That does provide some basic protections from like ransomware type attacks. Just be aware that there are some, and Brandon will talk a lot more about this in his webcast, but just be aware that there is a maximum number of versions, and most attackers will know what that maximum default is that it stores, and so they'll overwrite things multiple times. However, that gives us an opportunity, because it shouldn't be very common, at least in a lot of cases, that those versions are being overwritten multiple times in sequence. And so that gives us a way to alert and catch on to earlier to maybe prevent some of the loss. The other reason to use object lock would be for our logs to create a trusted log storage, right? Where once the log's written, it shouldn't need to be changed. And so we can lock that object and then have a lifecycle policy that eventually gets rid of it. But while it exists, it can't be changed. And that can help us prove to our auditors that our logs haven't been tampered with. All right, break glass accounts to wrap things up so that we can get to a few questions here. We're going to have to provide some sort of read-only access to our teams to do investigations. These are the accounts that they might use on a regular basis. Now, there might be some more like global read-only access that we provide in more of a break glass scenario, but a lot of the times these read-only group access permissions are provided to our analysts so that they can do their investigations. We've got to decide what the right approach is, what the right level of access. Are there managed policies or built-in roles we can use for that, or are those too permissive? Right? If we don't want our analysts and other teams to have access to actual data in our cloud environment or secrets or things like that, then we've got to make sure that we're applying a role or a policy that gives them access to the other things, but not to read secrets, not to read data from our cloud storage. And we talk a little bit more about that in the class and the different policies that are available there. Break glass accounts. This is once we've done our investigation, if there is an incident and we need to do containment or we need to clean things up, we might need an account that's more permissive, that has administrative privileges or something like that. We may also at some point need to get in as a root user or a global admin or a super admin. That's not going to be our first break glass account, but we might want to have one of those accounts available just in case something really bad has happened where our admin accounts have even been locked out and we can still get in. We probably want to have the basic accounts or some of the accounts with MFA, and then in case the MFA service is down or not functioning, or somehow we've lost the tokens or whatever, something without MFA. Now, the ones without MFA should never be used unless the MFA service is down. But the difficulty there is some of the cloud providers are now requiring MFA. And I wanted to give you a few ideas because I've been asked this question a few times now from clients, is what do we do with our break glass accounts now that they're requiring MFA? Well, you can use service principals, service accounts, and things like that, like roles, I guess, to get around that requirement. AWS, they're just requiring it for root users, so it's not really a problem in AWS, but for Google Cloud and for Azure, where they're having these requirements, you can use service principals and service accounts. Now, just be aware that while those bypass the MFA requirement, they do require that you do most of your stuff via the CLI. So you have to be comfortable with using the CLI, but that would be one way to get around that. Now, if you don't feel comfortable having a service principal or service account storing the certificate or key somewhere locked down in a secrets manager somewhere outside of the cloud, and you're still worried about that, then one thing that I've set up just to test it out is a kind of event grid event that I'm listening for that triggers a function that then will go reconfigure a virtual machine to allow my IP access to it. And that virtual machine has a managed identity assigned to it. And that managed identity, when I trigger that event, gets a role assigned to it with the permissions that I need. So by default, it doesn't have access to anything. The virtual machine's maybe not even turned on, and there's no access over SSH to that virtual machine. But when I trigger an event, I can pass in the tags and stuff of that event an OTP code, and I can validate that in my function. And that gives me MFA, but not the cloud provider's MFA. It's my MFA, which should still work even if the cloud provider is down. And then once I validate that OTP inside of my function, then I reconfigure that virtual machine to allow me access. I can SSH into that virtual machine using the SSH key that I'm storing securely somewhere, and then use the managed identity on that virtual machine to do my work in the cloud. All right, I know that didn't leave us tons of time for questions, but that's all I've got for today. I wish we had more time. I'll answer this one here, and if you have others, feel free to reach out to me on LinkedIn. My URL for my LinkedIn is there. I'm happy to answer your questions there. Let's see. Would it be best for a SOC team to have a separate subscription or account? For example, Sentinel and the associated log analytics workspace is in its own subscription. The SOC team itself, their credentials are going to be stored in the tenant. And so they're not really tied directly to a subscription. Yes, they should probably have a subscription for their resources, for their workloads that they're going to be managing, but then they will still need access to the other subscriptions, at least from a read-only perspective, to do their investigations. And then with their break glass accounts, they might have access to read and write to all the different subscriptions to do their response. But yeah, you would have a separate subscription and log analytics workspace for like your logging infrastructure if security manages that, maybe some of your security tooling, your maybe Azure Defender configuration and stuff like that. All right, and then we have a roadmap here of our different cloud courses if you're interested in knowing what we have available in the cloud curriculum. We also have these journeys that are available that kind of based on your role will recommend classes for you. They're not the classes you have to take, but it's just a suggestion. And then associated with these journeys, if you complete the courses and the certifications for each of those classes listed in your journey, you do get a coin. All right, and that's all I have for today. Thank you for joining again. Since I didn't get a chance to answer all of your questions, reach out, connect with me on LinkedIn. Might be good to just let me know that you joined the webcast, because I do get a lot of spam connections. And then we can connect, and you can ask any of your questions there so that I can get those answered. Happy to talk about the course or any specific questions that you have. But thanks for joining, and hope you have a wonderful week.